All right, so this is an 8th grade math lesson from Mr. Krause on Standard 8 DE7. Our learning target is that I can determine the number of solutions to an equation with variables on both sides. All right, so in the past we talked about our steps to success when we have variables on both sides, and we've listed these here on our little anchor chart. We distribute combine like terms, move the variables to the left side, which is important. We undo any addition and subtraction, and then we isolate that variable. And so we're going to do a couple of examples today of the more difficult type problems you may see, and we're going to use these steps to come up with the solutions and then determine if there is one solution, if there's no solutions, or if there's infinite number of solutions. All right, so for our first example, let me get our problems here. All right, so for number 1, we have 1/2 times 2p plus 8 equals negative p plus 8. All right, so anytime you're faced with a problem that has variables on both sides, then you can follow these steps to find your solution. So we're going to start off by distributing, because remember, our order of operations tells us that we want to get rid of the parentheses. Well, to do that, we have to distribute. So we're giving a half to all of this stuff that's inside the parentheses. All right, so we're going to change colors. So we're going to go 1/2 times 2p would be 1p, and then 1/2 times 8 would be 4. All right, bring everything else down to keep it nice and neat. All right, so we have completed our first step. We've distributed. That gets rid of my parentheses. All right, our next step says to combine like terms. Well, we can't combine a p and a 4, a 1p and a 4, because they're not like terms. We cannot combine a negative p and an 8 because they're not like terms. So we're good here. We can go ahead and go to the next step. So we're going to move the variables to the left side. All right, so remember we always do this by opposite operation or inverse operation. So if we have a negative p and we want to get him over here, we have to do the opposite. Well, the opposite of a negative is a positive, so I'm going to add a p to both sides. All right, so we have 1p plus 1p gives me 2p. Everything else we're going to bring down to keep it neat. Now, our negative p and our positive p, they cancel each other out. There's nothing left. So we just bring down our 8. All right, so that gets us through our first 3 steps. And as you can see, we're starting to simplify as we go. We're getting rid of the parentheses, and we didn't have to combine like terms. We got our variables to one side, and now we just have a basic 2-step equation. All right, so step number 4 says undo any addition or subtraction. All right, we have addition here. So to undo that, again, opposites always help us out. So we're going to subtract 4 from both sides. We're going to get rid of that. Sometimes you might hear me call this the lonely number, because he doesn't have a variable. He's all by himself. We're going to get rid of him. He's lonely. He needs to go somewhere. All right, so again, this is going to cancel, and we're left with 2p equals 4. So we've simplified from a complex equation all the way down to a simple 1-step equation. All right, our last step says to isolate the variable. Well, we want this p by itself, so we're going to do the opposite again. Divide by 2, and you're left with p equals 2. All right, now, most important thing, remember, always check your answers. That's the most important thing. If you get down and you have an answer, you've got to check your answers, because if you don't, if you've made any kind of mistake, it may look right, because it looks like we did a great math problem here, but did we do it correctly? So we can take this answer and we can like stick it back in here, you can stick it in up here, it doesn't really matter, as long as you move it back up towards the original problem. So if we plug this back in, we have 1 times 2 is 2, plus 4 is 6. bring it up here. -2 plus 8 is 6. So we know that we are correct with this answer. All right? We're going to do a couple more. So, this answer here obviously is one solution. So if you're looking for the number of solutions to an equation, you would solve this out and say this equation or this problem has one solution. This is the only number that will work to balance that equation. Use this. All right. So let's try one that looks a little different. It's time for a new whiteboard. All right, so let's look at this. Number 2. We have 8 minus 2 times n plus 3 equals n plus 7 minus 3n. All right, we got a lot going on here. Nothing different, same steps, same methods. So here we go. First thing again, we're going to distribute. So I'm going to get rid of this parentheses by distributing. So we're going to be distributing a -2 to everything inside the parentheses. Keep in mind, order of operations, distribute, get rid of the parentheses. This 8 that's out here by itself, a lot of people mess up by going ahead and saying 8 minus 2 is 6 and then distributing. You've got to keep your order of operations intact. All right, so we're not going to do anything with him yet. We're going to leave him alone. So -2 times n is -2n. -2 times 3 is -6. Nothing to distribute over here, so I'm going to leave it alone to keep it neat and just bring everything down. Remember, take it one step at a time. It will cause you, it will make the problem seem a little longer, but it's okay. I'd rather us take our time and do a little bit more cautious steps than make careless mistakes. All right, so now we've distributed. Now we can combine our like terms. So over here on the left side, we have a +8 and a -6 that we can combine to give me 2. We also just have a -2n, but he can't combine with any of that because they don't have n. So I'm going to start with my variables. We have +2, 8 minus 6. Over here, I've got, let me switch colors again. Over here, we have an n and a -3n would give me -2n. Nothing we can combine with a 7, so we just bring them down. All right? So we distributed, got rid of the parentheses, simplified down, combined our like terms, and we're keeping simplifying as we go. Next step, move our variables to the left side. We have a -2n that we need to get over here. So we do the opposite by adding 2n. And this is what happens, guys. Look, we have -2n and +2n cancel, a -2n and +2n cancel. We're left with 2 equals 7. All right, this is a problem. 2 does not equal 7. If you get rid of all your variables, if you simplify down step by step and you get rid of all your variables and you end up with a statement here that is not true, this is what we call no solution. And basically what that means is you can pick any number in the world, whatever number you want, and substitute that in for the n, and it's not going to balance. Never. A fraction, a decimal, a positive, a negative, 0, nothing will balance if this statement is not true, and obviously 2 is not equal to 7. All right, let's do one more. So we've looked at one that gave us one solution. We've looked at one that gave us no solutions. Well, let's look at one that gives us something else. All right, this one's a little tricky. All right, so let's look at problem number 3. We have 2/3 times 9x minus 3 equals 2 times 3x minus 1. All right, so we're going to follow our steps. So let's distribute. We have 2/3 times 9x gives me 18x over 3 minus 2 times 3 is 6 over 3 equals 2 times 3x is 6x. 2 times -1 is -2. All right. So again, we just distributed to get rid of our parentheses. We just had to do it on both sides this time. No big deal. Don't panic about the fractions. Go ahead and multiply them out, and most times they'll be real nice about it and they'll simplify, just like these. 18x over 3 reduces to 6x, minus 6 over 3 reduces to 2, equals 6x minus 2. Now, we didn't have any terms that were alike, so we didn't have to combine any like terms. So now we can go ahead and move down to moving our variables to the left side. So I'm going to get rid of this 6x over here by subtracting it. And you're left with -2 equals -2. These are going to cancel. Now, here's the difference in the last problem. The last problem we ended up with like 2 equals 7 or whatever it was, and it wasn't true, and it was no solutions. This one equals -2 equals -2, which is a true statement. If this statement is true, your answer is all real numbers. You may see it written as infinite solutions. Okay? Now the difference is, what this means is any number in the world, a decimal, a fraction, positive, negative, zero, any number all the way up to a gazillion, it doesn't matter. If you plug it in for those x's, it's going to balance every single time. All right? So these were the 3 sample problems that you had. The first problem that we did, you ended up with one solution. That's the only number that will work whatsoever. You cannot find another number that will work. The second problem we did, we got rid of all the variables and the answers were not true. If they did not balance, it's no solution. No number will work. This final example we did, we simplified it down and we got a true statement that -2 is equal to -2. So our final answer is all real numbers, or you may see it as infinite solutions, because infinite means never ending. It doesn't matter. Every number is going to work. All right, so the bottom line is following these steps when you have variables on both sides will always get you an answer that you can determine whether it's one solution, no solutions, all solutions. All right, hope this helps. Thanks.